All right, so number one, from your chapter 6 test, it gives you the following function, and it's asking you to find the what? Domain. All right. So it wants the domain. And whenever they give you a domain question and you have a fraction, you focus only where? In the denominator. So again, make sure on your notes you have some great notes. You're focusing on that bottom. So later, we shouldn't ask, what do we do at the top? All right. I have to injure you. I'm just kidding. So we only focus on the bottom. What do you do at the bottom? You factor. But before you factor, we can never have the bottom what? Equal to 0. So make sure you set that denominator equal to 0. All right. So we set that denominator equal to 0, and then you told me to factor. So why do we factor? What's telling me to factor? What's that? So I want to find the restrictions, but what's telling me to factor here? Because this problem, let's say you just had this. Let's say you just had this on your test, right? Ignore all the rest. What's telling you to factor? What does the return? So your largest exponent is 2. So it's a quadratic. So because this is a quadratic equation, that's why you factor. So make sure you have that written in your notes, all right? So this is a quadratic equation, so we know we have to factor, all right? So we get x, and then we get what? Minus 5, minus 2. We go ahead and solve, and we get x is 5, and x is 2. So when x is 5, if I plug that in here, that'll make this whole bottom what? 0. So what we say is x cannot equal 5. Because if it did equal 5, then we'd get 0 on the bottom. And if I were to do the same thing with this 2 here, if I plugged it into the bottom, what would happen? It would equal 0. So we want to make sure that you also put x cannot equal 2. So your domain, let's go back and answer the question. So your domain is all real numbers except what? 5 and 2. All right. So a few ways of writing this. If I did this in interval notation, I say x is all real numbers. So it goes all the way from negative infinity until I hit which troublemaker? The 2. All right. This is always going to be open because I'm not including the 2. Right? You cannot have it equal to 2. Then I have a gap. So what do I do to represent that gap? The union. I start back up at 2 until I hit which other troublemaker? 5. All right. Then I have another what? You, not me. And then start back up at 5 all the way until infinity. All right. So this is one way I could write my domain. Or you could just, in words, write x could be any real number except, bam, 5 and 2. All right, so there's the idea right there. So that's number 2. So again, I have all these questions people asked me, they brought up, so I'm going to answer their questions. All right, so that came from your chapter test, page 499, and that was the first problem. All right, the next problem someone wanted me to do, let me change gears, is from, I'll just write the next problem. And what I'm going to do is I'm not going to tell you where it's from because part of your exam is identifying, well, what type of problem is it and how do I go about solving? Absolutely. So 3x cube root of xy squared. All right. So there's our problem right there. And what I want you to do is to start to identify. So once you see the problem, start to identify, what are some things that I notice? So what are some characteristics about this problem that you're starting to notice? Yeah. This is huge. So look what Arturo's saying. The index of each one is the same. both of these have the same index. That's huge. So most likely I want these radicants to be the same. Right now, are they the same? No. So what I want to do is I want to simplify each one of these if possible. So write that down. I want to simplify each radical. Simplify each radical. All right. Because there might be a slight chance that when I do that, these will end up being the same. Possibly. So let's do that. All right. So we get 2. I don't like that marker. All right. I'm not a little kid anymore. So I got cube root of a perfect. So this, remember, the first one is always perfect. I'll figure that out in a second. And whatever is left over goes in here. Plus 3x. And am I going to be able to separate? Let me highlight this because I forget you're going to be watching later. Am I going to be able to separate this one? No, because notice you need to be able to divide it by 3. There's not enough. Your exponents are too small. So I'm not going to be able to simplify this one. So there's no point of me trying. So I'm going to leave this the same. The cube root of xy squared. All right. So based on our discussion last week, if my index is 3, I need these exponents. I need these exponents to be divisible by what? By this 3. So right now that 4, I can't divide it by 3. So I need to drop it down to what? X cubed. Am I going to be able to drop this y squared? No, right? So that's going to have to stay in the other. And let me point at that for you. So this y squared is going to have to stay over here. Notice I started off with 4x's, right? X times x times x times x. But I took out 3, so how many are left? So make sure you write that in the other radical. What else goes in here? Y squared. Perfect. All right. And what is this going to simplify to? This piece right here. What does that simplify to? X. So you're left with 2x, the cube root of xy squared plus 3x cube root of xy squared. Now the question becomes, can I simplify these? Yeah, so in your notes, make sure you put combine like radicals. And why are we allowed to? Well, because these radicals are now exactly the same. So now we could combine the leading coefficients, those leading pieces, right? So I got 2x plus 3x is going to be 5x. So this is equal to this, which is equal to this, which is equal to, you said 5x. Do I need to change the radical? No, they're the same. It stays the same. So you're left with the cube root of xy squared. All right. And that's where you stop right there. And then I'm going to put a star by that because that's a great test question. All right. So that's a great test question right there. All right. So that's a good question. All right. Next question someone has is the following. Or did you have a question on this one?
That would just say like simplify?
This would say to simplify, and this is what kind of stinks here, in terms of the directions, because it could say add, it could say simplify, right? But what I want you to be really good at is, without seeing anything, being able to look at this problem here and know what to do. Because here you have a plus sign, so there's nothing else we could do except add, right? And in order for you to add, I'm going to have to try to make these the same. It might not be possible, but in this case, it was. I need those radicals. I need these radicals to be the same. So in your notes, right, this is half the battle. This right here is like 1/3 of the battle. The real battle, 2/3 of it, is understanding what is it that I have in front of me and how do I go about tackling that problem, right? So Make sure your notes are really good tonight and you're asking these questions just like she is. All right, perfect. All right, next problem. Here we go. All right, so I'll make a new page. That's not working. All right, next example. Let's see here. Can we see that? Yeah. All right, so we have the square root of 8x cubed divided by 25y to the 6th. All right, so there we have it. And what we're going to say here, yes. The cube root? Okay, it's okay. I was happy because I was like, all right, this one's going to be fast. It's all right. So we have the cube root of all that fruity goodness inside there. All right. So what I'm going to do here is I'm going to use one of our definitions. Yes. Oh, you're just joking with me? Well, you know what? We're going to leave it now. Just kidding. We'll do both of them. I'll do both so you could see how it's not so bad. You're welcome. It costs extra. Just kidding. So what we do here is, because you're going to get a question of both versions, right? So if you had this, what I would do is I would first separate them. I would see if I could reduce it. Can we reduce anything here? No, nothing's going to cancel, right? Nothing cancels there. All right, so what I'm going to do is I'm just going to go ahead and separate these. So I get the cube root of 8x cubed. And down here I got the cube root of 25y to the 6th. And again, what you're going to need, what's going to be very helpful is you have that list, that index card of perfect powers. So in this case, we want perfect what? Cubes. So what's telling you on this one, we're going to look at the perfect cubes list. What's telling you that? The index. So good, you're focusing on that index. So we need on the index card, we need all those perfect powers, perfect squares, perfect cubes, and so forth. So that's going to be very helpful. All right. So let me get rid of this. Give me some more. Let me get some real estate in here. Nope, that's too big. All right. Let me get some eraser action. Okay. So am I going to be able to simplify the top or the bottom there, the denominator or the numerator? I hear someone saying the numerator, right? Do we know the cube root of 8? What is it? It's 2. The cube root of x cubed? X. So good. So the bottom was quite nice. Or sorry, the top was quite nice. I know the cube root. All right. Do I know the cube root of anything here on the bottom? The y to the 6th. Because what do I do with this exponent? Divide it by the index. So that 25, unfortunately, is going to stay where it is. But the y to the 6th is going to turn into y squared. Good, because you divide it. You divide it. Let me make a mistake here. What's the mistake that I just made? You forgot the index. Don't forget the index. It's really easy to do. So don't forget the index. All right. So again, I look at, I'm not going to give it away. What's the problem with this guy here? So write that down. Remind yourself you could never have a radical in the bottom, right? In the denominator, that radical cannot exist. All right. So we have something that we learned how to do, and that process is called what? Rationalizing the denominator. So what we're going to do is we're going to multiply top and bottom. I made another mistake. What is it? The index. Can't forget the index. Don't forget the index. All right. Right now I have the number 25. I would like to turn it not to 25. I would really like to have what number? 125 I'm hearing, right? So what do I multiply by? So I'm going to multiply top and bottom by the cube root of 5. Again, the reason why you do that, The reason why we do this is because we want this denominator, what's on the bottom, to be a perfect cube. Sandra.
I'm sorry, before you go any further,
Yes.
so you're only multiplying the radical?
Well, but yeah, whatever's inside the radicand. This one doesn't have a radical sign, so we're leaving it alone. Yeah, good. All right. So upstairs, we are left with 2x, the cube root of 5. Downstairs, you are left with y squared and the cube root of what? 125. And if you just want to, instead of writing that, you want to write the answers. If you just want to write 5y squared, that's fine. But I'm just doing this for our YouTube audience at home. All right. So now I'm doing step by step. So now we go ahead and we simplify this piece. All right. So this turns into 2x cube root of 5 divided by 5y squared. Can I simplify any further? No. So there we have it. And of course, we're going to put another what by this? Star, right? So whoever's asking these questions, man, they're not only getting their questions answered, but now they're going to be ready for this test. Yes.
So you had said that we multiply the top and the bottom with the cube root so we can get the radical?
Did I say that? Yeah. So what we're trying to do is we multiply by some cube root because your goal is to get rid of the cube root that was originally there in the bottom. That's your goal. Yes, your question.
And so we choose 5.
Because we look at the 25 and you ask yourself, from that list that you have of perfect cubes, what can you turn that 25 into? And because you could turn it into 125, that's why you ask yourself, oh, I multiply by 5. But here's a trick I like to do, all right? So watch. Read me that list that you're looking at, a perfect cube. Start from the top.
So square root of 1 is 1.
Okay, so 1.
Square root of 8 is 2.
So cube root of 8 is 2.
I mean, the cube root of 27 is 3.
Cube root of 27 is 3.
Cube root of 64 is 4.
Cube root of 64 is 4. Okay, so here's the secret. And then you have 125 is 5, right?
Yeah.
Okay, so what I do here is I'll go further if I need to, but I ask myself that 25, can I turn into 1? Absolutely not, because we're trying to grow it, right? So what you do is you do 1 in your calculator, 1 divided by 25, that's not happening. 2 divided by 25, that's not happening. 3 divided, or sorry, I'm on the wrong side. 8 divided by 25, that's not happening. 27 divided by 25, that's not happening. 64 divided by 25, that's not happening. Finally, I type in 125 divided by 5, and that gives you this number. So that's an easier way of doing it, just kind of chugging through your list. So that's how I knew, 25 times 5 is going to give you one of these numbers that you're looking for.
Oh, okay.
Does that make sense?
Yeah.
Cool. Karina.
So you know how you said we can have a 5 by 7 card?
So you could have a 3 by 5 card, yes. And as separate, you could use the perfect cubes. Yeah. All right. So that's just today's bonus. If you're listening at home, you can't use shit. But anyways. All right, good. All right, so here we go. Let's continue with good questions. All right. So now I want to introduce you to your new section. So copy down the title. What's that? Oh, I'm going to talk about all that great stuff soon. I'm going to talk about all that great stuff at the end. So what we're going to look at right now is radical equations. Radical equations. And I decided to start things off a little different today. So, like I said in those previous problems, not only do I want you to know how to do them, but the main 2/3 of the battle is you being able to identify what is a radical equation. So this part that you're writing down is just as important as the examples, because examples are not helpful at all, as some of you are seeing, unless you know where to apply them, right? So we are looking right here at radical equations. So this is what we look at. A radical equation is an equation in which where the variable is on the inside of a radical. So just to give you an example, you're going to have a variable somewhere inside here. Here my index is 2, but it could be 3, it could be 4, it could be 5, right? And your variable is somewhere inside here. So that's why it says occurs in the radicand, because everything inside of the root is a radicand, right? So that's what we're looking at. And of course, you need an equation, so it has to be equal to something. All right. So there is the process. So what we have here is we have the following. Let's go with this example. So we're going to have something very small where we have the square root of, let's say we have x plus 2. Is that a radical equation? Is that a radical equation? No, why not? It's not equal to anything, exactly. So I need this equal to something. So let's set this equal to, I don't know, let's just say 3 for now. All right. So I'm going to spell out the process for you, but let's walk through it, because I need us to make sure we understand some things. So right now, what's my index? It's an invisible 2, right? So if there's nothing there, it's an invisible 2. All right. So what you do is you look at that index, and what we're going to do, let me copy that down one more time. And our goal is to get rid of this radical, right? So what I'm going to do for this example, and we'll explain why in a few minutes, is I'm going to square both sides. Because what's my index? It's invisible what? 2. So you could think about this. You could think about this as, oh, this 2 and this 2 cancel. And so I'm left with x plus 2 equals 9. All right. There's much more to it, but that's the way you could think about it. I think that's the easiest way of thinking about this. So if my index were a 3, you would do what to both sides? Not multiply by 3, but you would cube it. You would raise it to the 3rd power. All right. And now we just go ahead and we solve. Minus 2 minus 2. So we get x equals 7. And again, you don't have to wait for me to say, oh, okay, did I get that problem right? What can I do with the 7? We could plug it in, right? So we end up with 7 plus 2. We get 9. Is the square root of 9 3? Right? You got your answer. All right, so you could always just plug it in to see how did I do, right? So maybe I should just have you grade yourself. Yes. Where do you get the 2s? eBay. Other questions? No more questions? Okay. So, whenever there's nothing here, so write this down. Whenever there's nothing here, there's invisible 2. So just know the index is 2 when you don't see anything. And where this 2 came from is this 2 is always going to match this 2. So if this were a 3, this would be a 3. If this were a 4, and so forth. Cool. All right. Next example. Not just kidding. So let's do another example. And with this example, I'll give you some steps. All right. So let's go with something a little different. And this problem, do I want to go there yet? Not quite yet. Let's go here. Be very careful when you write this down, and I'll tell you why. I'm going to add a tick right here, a little mark. And that mark, you won't see it in textbooks, but the reason I'm doing it is so you know what your radicand is. So the reason I put this little mark is so you know that this plus 6 is not inside the radical. All right? So I put that little mark just so you know where that line stops. Because if you're not careful, this problem looks just like this problem. No? Yeah, so you got to be very careful. They're not the same, completely different. All right. So you got to be very careful there. All right, so let's get our process down. All right, so the first thing we look for when we're doing this is you want to isolate the radical. This is our radical. So step one. Step one. If necessary, so isolate the radical. Get this guy by itself. We want this guy all by itself. Our radical all by itself. So you're going to write isolate, if that makes sense to you, the radical. If that doesn't make sense to you, then you have to use your own words, right? Point to it. We want this by itself. Whatever is going to make sense to you, right? So step one is get this piece all by itself, our radical. All right. So you want the radical on one side. That's step one. Questions on that? All right. So how do we do that? How do we do that very first step? So I hear square both sides. I hear subtract 6. So I'm going to go with my eraser first. And I'm going to, in a different color, subtract 6 from both sides. So I end up with the square root of x minus 3 equaling -1. All right. So I'm going to take this problem all the way through just to show you something. All right. So I could actually stop if I want, but I'm going to take this all the way through to show you something. I'm going to pretend that I missed class and I didn't hear the whole lecture. So this was going to happen to the people that missed today. All right. So they're going to be like, okay, I follow my next steps because they got their notes from somebody. And step number 2 says this. Now we identify the index. What's the index here? So now what they're going to do is they're going to raise both sides to what power? The second. So let's do that. But I'm going to show you the power of being able to check your work. So I'm going to raise, let's say we forget this very important rule that I'm going to show you in a few minutes. All right, so you went ahead, you do this. What's going to happen to this radical? Good, it cancels. So you're left with x minus 3 equals what? 1. Oh, now that's really easy to solve because this is what type of equation? It's not quadratic. Good, linear. So now I just solve it. These are the easiest equations to solve. So you get x equals 4. Perfect. Some people, they're going to stop. They're going to box that. They're going to do their dance. Bam, turn in their test. What do you got to do? Check yourself before you wreck yourself. Right. So let's do a quick check. All right. Let's do our discount double check. So we get the square root. I'm going to plug it in of 4 minus 3. And that equals -1. Let's see if this is true. What's the square root of 4 minus 3? That's just the square root of what? 1. All right. So that's what we have. What's the square root of 1? 1. So is this true? No. Damn liars. All right. So this is false. This is not true. So what you say is that liar. No, you say no solution. All right. But the person that doesn't come tonight, right, they just stop right there. And they're like, the answer's 4. Give me my A. All right. But you now know better that you could check. All right. Let me save some of you some time tonight. For those of you that are going to study and you put this in your index card, I'm going to save you even some more time. All right. So let me do this problem one more time. This time I'm going to do it with my eyes closed. YouTube can't see, so it doesn't matter. So we have the square root of x minus 3 plus 6. All right. And this is like the infomercial where I'm going to show you how to do this in less than a minute, or you get your money back. All right. You guys ready? All right, here it goes. No solution. No, I'm just kidding. All right, so let's see. So I subtract 6, bam. And I get the square root of x minus 3 equals -1. This is a red flag. All right. Well, actually, this is a red flag, but you know what I mean. All right. This is telling me I have a problem because when you have the square root, what's the square root of 9? What's the square root of 25? What's the square root of 100? Right? I don't hear anybody saying negative 10, negative 5, right? So this square root, this principal root right here, can't be what? Negative. Make sure that's clear in your notes. It cannot be negative. So once you get some type of false statement here, it would be foolish to continue. It would be foolish to continue. So right from here, what are we going to state? No solution. Right? So whatever you're doing in life, if it's taking you down the wrong path, it would be foolish to continue. Right? That's the moral of the story here. All right. So let me include one more thing. This is always going to be true when our index, not Windex, but when the index is even. All right. This is always going to be true when the index is even. So like 2, 4, 6, 8. Who do we appreciate? Johnny? Yay, Johnny? No? All right. So when the index is even, you can't have a negative. When the index is odd, who cares? Right? That's possible. So we're only interested when the index is what? Even. All right. If it's even, then you really need some Windex. All right. If it's cubed, it's fine. All right. So beware, right? You are going to have problems like that. And you know why? Because they're easier to grade. All right, here we go. So you have x plus the square root of 26 minus 11x equals 4. Everything's starting to look the same if you're not careful. What type of problem is this? It's a radical because it has a variable inside of the radical. So it's a radical and it's equal to something. So it's a radical equation. So whenever you have a radical equation, right, we have a process. All right. So we need to follow that process. What's the first step of that process? Isolate the radical. So do that. Get that radical by itself. Get over here, radical. All right. So we got 26 minus 11x. And what am I going to do with that x? Subtract it, right? So we end up with 4 minus x. So we just move this to the other side. So I subtract x from both sides. I rewrite the equation because I want that radical by itself. All right. So that's step 1. All right. Step 2, some of you are steps people, right? So I need to identify the what? The index, because once you know what the index is, let me just rewrite this for the sake of our notes. All right. Once you identify the index, then you know you're going to do what to this problem? Square both sides. You use the index, right? So you square both sides because you want to cancel that index. So I square both sides. All right. So I square both sides. All right. Some of you would square both sides like this. Some of you, I was looking at your notes, you got to be very careful. Because in your notes, some of you squared both sides like this. All right, so be careful. All right. So you're left with 26 minus 11x. And some of you, if you're not careful, you're going to use the shortcut. Don't write this piece. And you're going to do, oh, that's just 16 minus x squared. I square this and I square this. No, 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 no. Right? Some of us were thinking that. What do we got to do? Write it twice. Good. Write it 2 times. Right? Because then we FOIL it. We use the box method, whatever you like. You distribute however you like. All right? You can do whatever you like. So here we go. We get 16 minus 4x minus 4x plus x squared. So all I did is I FOILed those binomials. All right, we multiplied them.
So step 3 was FOIL.
From here, okay, great question. Right after we go ahead and you isolate the radical, then you identify the index and raise both sides to that index, right? From here, you're going to write solve, because this takes us back to the beginning of the semester where you have to decide from here, what type of equation do I have? And this is where all of them are going to be a little different. So this is where we use our information from the past. What type of equation do you guys see right there? A quadratic. So write that down. This is quadratic, because we know what to do with quadratics, right? What do you do with quadratics? Set them to 0, right? So let's do that. So let's set them to 0. We could combine like terms, and then we'll go ahead and set this equal to 0. So let me do this. I'm going to rewrite it one more time. I'm going to rewrite it one more time, and then I'm going to set one of these sides to 0. So I choose u. All right, so plus 11x minus 26. So I went ahead and I set the left-hand side equal to 0. All right. Because this was a what? Quadratic. So please, in your notes, make sure you write that down. This is a quadratic. The biggest exponent, the largest exponent you see is something squared. So I get x squared. These two are going to become what? Plus 3x minus 10. Bam. And now hopefully we could factor this. So we get 0 equals x plus 5, x minus 2. All right, excellent. Now we are halfway done. Not just kidding. Okay. Now we do what with each one of those factors? All right, so let me set this mother factor equal to 0. And you get x equals what? Negative 5. And here, x minus 2 equals 0. So you get x equals what? 2. Are you done? What do we got to do with each one? Check it. Plug it back in. Plug it in. Plug it in. Here we go. So plug them in. Write this down if you need to. Plug it in one at a time. You can't check them both at the same time. We plug them in one at a time to see if they work. All right. I'll bring that right back up. Let me just look at my original. If I plug in negative 5, I'm going to get plus 55, right? Because of negative. So I'm not worried about this one. I'm okay. I'm doing a little shortcut. I'm really only worried when I plug it in, it gives me a negative on the inside. That's when I'm worried. All right, I plug in 2. Let me go plug in 2. And let me ask you this question. When I stick the 2 right there, is that going to make, let me get my highlighter, is that going to make my radicand negative? No, right? Let's do this. I plug in 2. What's 11 times 2? 22. So I get 26 minus 22, which is what? 4. What's the square root of 4? 2. So you end up with 2 plus 2. Excellent. So we know how to plug it in. All right, but what I'm saying is to save yourself some time, I'm really only interested, and I want to make sure this is not what? Negative. That's going to save you a whole bunch of time. But if you want to go all the way through, that's absolutely fine. Make sure that radicand is not negative, exactly. All right, so let me bring this back up for those of you that are copying. All right. Questions. Should we start by it? Absolutely. All right. I have an answer.
So if it's not negative, then that means that it's a solution. We are a solution or
When you plug it in, if it doesn't give you a negative, then that's going to be your indication that, okay, things are going to work out just fine. Yeah. That's the way I'm going to set them up. Later on, like eventually, you would plug them in and do all the work to be real safe, but I'm not sure we're going to have enough time, so I'm giving you some shortcuts. I just want to make sure everyone has, know what to look for to kind of, so you don't get all stressed out and run out of time. All right. So, next example. And again, I'm going to talk more about these, but I'm giving you the goods, the inside scoop. All right. So let's see here. Do I want to go crazy yet? All right, why not? I hear a lot of pages flapping, so that's perfect. We might want a new page. 3x plus 1 minus the square root of x plus 4. Ooh, what's in this that we have not seen before? Now we have two radicals. Actually, write that down. This equation has two radicals. Even the screen is scared, as you could hear. All right. So we have two radicals. Dun, 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 dun. All right. Step 1. The steps do not change. What's step 1? Isolate a radical. So you choose one of these to isolate. It doesn't matter, but I'll just go with whatever's easier. So I'll move this guy over. And again, I'm doing this because this is a radical equation. So part of your formula for success is identifying what is it that I have here in front of me. All right. So that's what we have. So on my left-hand side, I have the square root of 3x plus 1 equals 1 plus the square root of x plus 4. This is a really good problem because this one problem right here covers like 4 different sections in your book. Right. So this problem right here covers stuff that we did in Monday's homework. All right, so now that I've done that, I've got this radical all by itself. How do I get rid of that radical sign? I square it. Why do I square it? The index is 2. All right, so what I'm going to do, again, just for the sake of my notes, your work is actually going to be a lot less than my writing because I'm doing extra steps. So just on your notes, it's a little bit more clear. So more than hard, it's just a lot of writing, right? It's a lot of writing. So I square this side, you guys tell me, and I square this side. Is there a shortcut? Can I just square this and then square this and that's it? No, it's squared, so I have to write what? I got to write 2 of them, right? I have to write 2 of them. Okay. So what I really want you to do, because I see this happen all the time, in this next step, what people do is they're doing great on their test, and then there's somewhere along here where they just quit instead of trusting the process. You got to trust the process. All right. So if it says square, that just tells you to do what? Write 2 of them. So you get 3x plus 1, right? These guys cancel. This cancels with that index. So you got 3x plus 1. And I'm just going to take that extra step, right? It's those little things that make such a big difference. I'm going to take that one additional step. All right. And I'm going to write 2 of those. Sandra.
Yeah, Johnny, on the first one there, you canceled the square.
Yeah, because my index here is an invisible 2.
Right.
Right.
But over here on this side,
On this one, right?
there, yeah.
Great question. I'm just getting the same question from one of my YouTube audience members. Not just kidding. See how this guy is just one term? So because it's only one term, I'm allowed to cancel it. This one, unfortunately, because we don't have that one rule where like I could just square this guy and I square this guy, I have to write 2 of them. So unfortunately, this and this will not cancel. I'm forced because it's a binomial.
Because it has that one,
Because it has that plus sign.
which makes it
2 terms. So great question. And a lot of people were asking that. Thank you. We're wondering that. So this one, unfortunately, can't cancel with this one because it's a binomial. So that's a huge point to make on your notes. Because Sandra wasn't alone thinking that. Good question. Never ask that again. Just kidding. So now we go ahead and we multiply. Now I could FOIL. Or what's the other method some of you enjoy? The box method. It's up to you what you want to do. All right. So on my left-hand side, I'm left with 3x plus 1 equals. Let me move this up just a little bit. Come along for the ride. All right. So I'm going to FOIL this. So I got 1 times 1. I got that 1. If I multiply this radical times 1, is this radical going to change? No. So plus the square root of x plus 4. Would it make a difference? Does it change it if I put a 1 there? No. So if you want to write this 1 in front, then do so. I'm going to leave it in there, and I talked about this on Monday. All right. I'll remind you in a few minutes, a few seconds why I did that. Yes.
that one is when we add 2 radicals, we need that 1 there.
You need to think of that 1 there. Yeah. Yeah.
I mean, sorry.
Yeah, because it's confusing because you have this 1 and you have this invisible 2, right? So it's very, if you're not careful, it could be confusing, right? And then we're going to continue our distribution. So we get this radical and this 1. So we have another 1 square root of x plus 4. Right? And now we have this radical times this radical. So what's the square root of x plus 4 times the square root of x plus 4? X plus 4. Right? We said the other day when the radicants are the same and you're squaring it, right? When they're the same, they come out of the radical sign. So now they do come out of the radical sign. All right. So now, right, if you take a step back and analyze this, you're like, damn, this did not help me at all. This made the problem harder, right? But let's do one thing and let's ask ourselves the same question. What can I do next? Combine like terms. So write that down. I could combine my like terms. So these 2 radical signs all of a sudden are going to turn into 1 radical. All right. So you end up with 3x plus 1 equals 1. Actually, I said we're going to combine like terms. So I don't have 1. I have what? 5. 5. And then these 2 are going to be how many of these radicals? 2. So plus 2 square root of x plus 4. And then I have one more thing floating around. What's the last thing? Plus x. Plus x. All right. This problem just went big time on us. All right. So I have this one right here. Let me just kind of recap. This one and this one became this 2 right here. All right, just in case you missed that. And then this one and this 4 became that 5, just in case you missed that. And this x didn't have a friend, so it stayed right there. And that's why it's the x. All right. Now, I want you to ask yourself that same question. Before I had how many radicals? 2. How many radicals do you have now? 1. So even though it took some work, we got rid of 1 radical. So now let's work on getting rid of this last radical. So I go back to my steps again. If I see a radical sign, what's my step? Isolate the radical. So I'm going to write that down. Isolate the radical. So I write that down. Isolate the radical. There. So I wrote it right there in white for you. All right. So I need to isolate the radical. So let's do so. So I'm going to subtract x from both sides because, again, my goal is to get this radical by itself. Minus x. And then I'm going to subtract 5 from both sides as well. Again, I'm trying to get that radical all by itself. All right. All right. So now I'm left with 2x minus 4 equals 2 square root of x plus 4. And last, how do I get rid of that get that radical by itself now? Divide by 2 right before you square it because it's not quite by itself yet. So you want this guy to be completely alone. And it has that 2 in front of it. So that's why I have to still divide everything by 2. I need to get rid of that 2. I want that radical all by itself. So we get x minus 2. And now that radical is all by itself. And let me move everything up, get myself some real estate. All right, so now how do I get rid of this radical? I square both sides because my index is 2, so I square this side, and I square this side. So don't forget, when you square this side, how many copies do you need? You need 2 copies. So you're going to end up with x minus 2 and x minus 2. And that's going to equal x plus 4. So we go ahead and we FOIL this. Do we know how to multiply? Absolutely. So check out what I'm doing. I'm just going to write the final result here after you multiply. We do know how to multiply. So after you FOIL, this is what we get. After you clean things up. And what kind of equation is this now? Quadratic. So because it's quadratic, what do? Set one side to 0. So minus x minus 4 minus x and minus 4. So let me write the result up here. So you're left with x squared minus what? Minus 5x equals 0 because those 4's canceled. These 4's right here, they canceled. And now you do what? Now you factor. So I could factor out the x. Right? Because they have the GCF is x. So I factor out the x. So I have x equals 0. And I have x turns out to be what after you do the work? 5. All right? And those are the easy 25 steps. All right. All right. Some reminders. All right. In your homework tonight, you're going to see some problems that might be deceiving. So, for example, all right. For example, let's see one of the hardest problems that you're going to see. Let me take a look here. All right, there we go. So we're going to have the quantity 3x minus 6 raised to the 1/3 power plus 4 equals 6. All right. So you can't let yourself be shaken up by something like this, because this is exactly what we just did, but its appearance just looks different, so it could totally throw you off. If we recall a couple weeks ago, we saw this is called rational form. It's a rational exponent, right? Because it has a fraction. And what we did is we converted rational exponents to what? Radical. Good. So here, what's my index? 3. So my index is 3. So this right here is the same exact thing as 3x minus 6 plus 4 equals 6. Those two statements, those two equations are exactly the same. So again, you have to be comfortable with this language, and you never know when this language is going to be useful, right? It's coming back here and there. It's popping its ugly little head everywhere. Karina, yes.
So we change it from rational form to what?
To radical form. So it went from rational exponent form to radical form. You didn't have to do that, but I just want to make the connection that those two things are exactly the same. What if this were not 1/3 but 1/4? What would my index be? 4. And if it was 1/2, it would just be 2, right? And so look how easy it is to solve this. And again, it's not going to get all crazy. What if it's 2/3? Then we're screwed. No, we're going to learn that in pre-calc and stuff for those of you who head that direction. All right, so not here, so we're lucky. All right. So what we do here is we just isolate the radical. We do the same exact steps that we've been taking. So we isolate the radical, and we get 3x minus 6 equals 2. Then based on our discussion, what do I do now? You cube it. Not so bad, right? Not so bad. All right, so we cubed it like it's 1999. And you're left with what on this side? 3x minus 6. Not bad at all. Now I do what? Plus 6 to both sides because we got a linear equation. Right? And we get x equals what? 14/3. 14/3. So again, let me tell you where this part is hardly ever the issue. The issue always comes from this first step, right? That's why I see so many blank papers, because this first step people get stuck on. How do I identify it? After I identify it, what's the process look like? So what's going to be very helpful is this. I'm not going to require you to do this. I'm not going to ask you to do it, but let me tell you what one of my students did at Heart Now. Let me just show you real fast. So what they did is this. They're taking the same exam. So what he did is he had problem type, and then he had another side that had steps. And so one of his things was like, oh, radical equations. Radical equations. And then over here, he listed the steps. I do X, Y, and Z. Does that make sense? But before he did this, what he made sure he knew how to identify is what are all the different types of radical equations. So if I were you, I would go and, on these homeworks and write down all these radical equations and ask yourself, do I really know how to identify these radical equations? What differentiates these from these? Does that make sense? because you can't begin to solve these problems unless you know what type of problems these are. And then the other thing, these look very similar to radical expressions. And radical expressions, then he had his list of things to do. He's like, what am I doing to these radical expressions? Am I adding them? Am I multiplying them? Am I dividing them? Or am I just trying to make one radical? Am I just trying to simplify it? So he had all that laid out. And that's the battle for this test. Because if you have a whole bunch of examples are nothing unless you know when to use them. Does that make sense? So this is what I highly encourage you guys to do. All right. And it's going to take some time because it's going to take you, now that you've done your homework, you're going to have to go back and kind of lay out your battlefield like, okay, how do I know I have to do this? And that's the real challenge. But it's not so bad. All right. So hopefully that makes sense. But that's how you pass any math class, right? Because then you begin to understand it when you do that. All right. I'll be taking pictures later. Okay. All right. So let's continue the march. So that's 7.6. And I'm gonna do this. We're gonna skip our usual little break because we're gonna finish so I could really summarize and answer questions after class a little early today because I know some of you have individual questions you wanna tackle. All right. And again, this video is going to be on YouTube. All right. Let me make sure I'm mic'd. All right. So 7.7. And what we're looking at is we're going to be introduced to this idea of complex numbers. Complex numbers. Your stomach's growling? I thought that was mine. All right. So we need to start off with the definition. And here's our definition. The square root of -1. Before we said it was not a real number. And it's still not a real number. And that is because what is the square root of -1? I. You what? I don't know? Okay. So the square root of -1, yes, he is correct, is I. And that represents our imaginary number. If you would like, you could put one I, all right, but I prefer four I's, excuse me. But that's something totally different. So the square root of -1 is what? I. That's your definition. So whenever you see the square root of -1, that's imaginary number. So that means that I squared. So if I square this side and I square this side, what does I squared give me? -1. So remember this definition right here. All right. So I is a square root of -1. I squared is -1, and ice cream is delicious. All right. So let's use this just so you can see how this game is played. All right. What's the square root of -49? 7, and because it's negative, you include the I. What is the square root of -25? 5i. What is the square root of -4? 2i. So you see, it's all fun and games until someone loses an eye. All right. Let's keep going. What is the square root? Let's go big. The negative square root of 100 is? 10. Good. I try to get you. It's just -10. Because the negative is on the outside. Very good. So you only get an imaginary number when? Write that Finish that sentence. When the negative is in the inside of your radical. So you only get imaginary numbers, and that's halfway true, when the negative is on the inside. I'm gonna expand on that. But that's what we're looking for right there. I'm going to expand on that, but not just yet. I'm going to let you believe that story right now. All right. I'm also going to say Santa Claus is real. Let's see. Next. Let's go with 5 plus the square root of negative 36 that I wrote in white. So this is equivalent. This is the same as what? Good. 5 plus 6i. All right. So the 5 came down, and then the square root of 36, negative 36 is just 6i, right? Can I combine those two? No, we're done. Here's one for you. Let's see if Noe could get this one. Let's go with the square root of negative. Let's go with r to, I don't know. Let's go with r to the 8th. What do we get there? R to the 4th. I? Yeah?
But why does the I go on this side then?
On this side? On this side? On your left side? What if I make it on your right side?
It's okay?
Is it okay?
I think you're just making it up.
Are you letterist? What's nice is it's up to you what side you want your eye on. Sometimes, I'll just tell you this. I before E, except after, no, just kidding. So it's up to you what letter. And if you want, right, can I just write, isn't this the same thing as this? Yeah? So it's I. All right. Yeah. All these are the same. Yeah. I was just waiting for that. That's why. I'm done now. That's took you long enough. All right. So, the next question is, how do we add these i's? How do we add these i's? All right. So we add these, if you could see them. You add these just as you do regular variables. So you just do the number with the number and the variable with the variable. Right? So all you're doing is, what's an easier way of thinking about this? Combining like terms, like x's, right? So what do you get? 8 plus 3i. Right? 8 plus 3i. All right. I'll accept that. All right. That's acceptable, right, Noe? Okay. Bastard, look. 3 plus 2i minus 5 minus 7i. Stop doing your homework and look at my jokes. What do I got to do here? Distribute, right? So it's all the same stuff we've been doing, so don't let the i's mess with you. So we get 3 plus 2i minus 5 plus 7i. So I distributed first. Now we combine our i's. And then I end up with negative 2 plus 9i. But this could be mistaken for what type of problem? Not subtraction, but what? If you're not, yeah. You could mistake it accidentally for multiplication if you're not careful. All right. Yes, Sandra.
Before you distribute, you did, you did the second half because of the negative,
Exactly.
changed the sign.
Exactly. I changed the sign. Yeah. I had a student leave this question totally blank, and this is probably one of the easiest questions, right? I was like, "What happened?" He's well, my answer's right there. It's imaginary. Okay, so that was a good one. So I gave him imaginary points.
I'm not supposed to say that happened.
You're not supposed to say it was you. 5. Now we have multiplication. Let me raise it up. So we have multiplication here. So we multiply like we normally would. Right? So 2i times 5 is what? 10i. And then 2i times 3i is what? 6i squared. Good. And I just heard that I squared is the same thing as what? Negative 1. So this becomes 10i plus 6 times negative 1. I'm going to show you a shortcut pretty soon. No, not OI. And so this becomes 10i minus 6. And there we have it.
So that's just doing the opposite, right?
Now we're multiplying. Yeah, now we're multiplying because of these parentheses. There's no plus or minus in the middle. So now we are multiplying. So what'd you guys tell me? I squared equals what? Negative 1. So if you ever see this, 6i squared, don't go through the whole progression. Don't go through all the steps that I just did. What I want you to do is, what is this I squared really doing to the 6? It changes the sign. So my answer, final answer is just what? Negative 6. Whoa. I ran out of ink. So if I have negative 10i squared, that's the same thing as what? Bam, 10. So in your notes, make sure it's clear that all the I squared is doing is what to your sign? Changing it. That's going to save you lots of time and money because time equals money. All right. So let's use that just to save us some time. So let's have 8i times 4i minus 3. All right. So here, I'm going to be left with, if you're doing this the long way, you're going to say it's 32i squared, right? But we just said I squared does what to the sign? Negative 32. But if you want to write it step by step, that's okay. But I'm just trying to use that information I just gave you just to save you some time. So in your notes, if this is confusing, then actually write out I squared and do it step by step. But remember, I times I is negative 1. So that's where that negative came from. Minus, what does this become? 24i. And we're done. So all I did is I gave you a little shortcut that you may or may not use. If you want to do it the long way like I did over here, that's okay. Right? But I just gave you another option. All right. So that's it for the new stuff. So let's focus on part 1 of the test. Part 2. All right. So part 2. Part 2. Time flies when you're having fun. All right. So we are looking at Chapter 7 test. What page, Steven? I think it was 578. 1 through what? All right. Chapter 7 test. Page 578 and 1 through 23. All right. So what I'm going to do right now, I'm going to tell you what's going to be on the test. All right. So you have a total of around 20 questions. 1 through 23 all. So you have about 20 questions on the test. They are all going to be multiple choice except for 19 of them. Okay. Okay. No, just kidding. No, it's just like a regular test, sorry. So you got 20 questions, and what I'm going to do is I'm going to pick 20 from the total that I've given you to study, right? So the last one, if you missed last class, it was chapter 6 test, right? 1 through 15. So it was around 20 questions total, right? Around there. So I'm only going to pick 20. What you're allowed to use is you're allowed to use a 3x5 index card, front and back and the edges. And on top of that, you could also use what? The perfect cubes, perfect squares, perfect fours. But please just have only that if I'm allowing you to use all that. I trust you guys, but just don't take advantage. Start using all your notes, extra notes, right? And then, of course, your calculator. Yes. Perfect powers. Perfect powers. All right. But not only have it, but know how to use it effectively, right? Because it's pointless. So what I would do is I would do this. This is exactly how I got in the habit of studying. All right, because I want you, if you don't have these habits, I want you to develop them, start developing them today. All right, so here's an example of how I would study. It took lots of time to develop this, but you get used to anything. So I would take a problem, and I'll write down a random problem. So something like this. And I would ask myself, what category does this fit in? I wouldn't even look at the instructions, right? I would just pick a problem, and I would ask myself, without looking at the instructions, I would say, what category does this fall under? So it would be simplify, and that's what the instructions would say, and this is a radical expression. This is a radical expression. So this is what it is. This is the type of problem it is. And what do I do with radical expressions? Well, when I don't have a plus or a minus or a multiplication, the only thing I can do is simplify them. Right? So then I go through the progression and I make sure I understand the steps. So that's why I told you guys, know how to identify it, and maybe on your index card, you have the type of problems, and then on the other side, you have, what do I do? So for radical expressions, what I do is I look at the perfects and imperfects, right? And I look at perfect cubes. See you tomorrow. What's a perfect cube that fits inside 16? Good. So 8 times 2. And this x to the 8th turns into x to the what? 6, and then x to the second, x squared. And this one I'm always able to break down. And what does this become? 2x squared. Does anything ever happen here? You just bring it down. 2x squared. And this is how you simplify them. So the key for your success is being able to identify all these. All right. Here's an additional note. Here's another very good piece of study tips. In your book, have any of you ever gone to the end of the chapter and saw that they have a chapter 7, or chapter whatever, but I'll just use chapter 7 example. Chapter 7 summary. Have you guys ever checked that out? It's pretty good because what they do, and this is where I would steal a lot of this information. The chapter 7 summary, let me just show you real fast. It gives you a lot of the properties that we would be using. So let me show you on the big screen. So from my book, it shows you multiplying and simplifying radical expressions. So right away, it gives you the definition the same one that I gave you, and it shows you the various forms that it might come in. Because I told you, 2/3 of the battle is you just being able to identify, right? What is it that I have to do? Sometimes, if there's steps involved, check this out. The ones that we just did. 7.6. It shows you what a radical equation is, and it lists the steps, right? So again, these chapter summaries are very powerful, especially if you miss the class, right? And then over here, it goes by and tells you the steps. So this is at the end of your book in case you want to look at that too. All right. So again, these are great study tips that I want to help you develop these math books. But again, if you need